Have you ever wondered how atoms stick together to form molecules? The answer lies in a phenomenon known as chemical bonding. Today, we delve into the fascinating world of chemistry to understand this process better. Chemical bonding, in simple terms, is the attractive force that holds atoms or ions together. It's the glue that forms the basis for everything we see, touch, and feel around us. To understand how atoms stick together, we need to understand the different types of chemical bonds. First up is the ionic bond. This bond forms when an atom donates an electron to another atom. The atom that loses an electron becomes a positively charged ion, while the atom that gains an electron becomes a negatively charged ion. These opposite charges attract each other, forming an ionic bond. Table salt or sodium chloride provides a classic example of ionic bonding. Sodium donates an electron to chlorine, resulting in a bond that keeps them together. Next, we have the covalent bond. This bond forms when two atoms share electrons. Unlike ionic bonding, where an electron moves from one atom to another, here the electrons stay put. They simply extend their reach to include the other atom's nucleus. This sharing of electrons allows the atoms to fill their outer electron shells and become more stable. Water, with its two hydrogen atoms covalently bonded to an oxygen atom, is a prime example of covalent bonding. A slight twist on the covalent bond is the polar covalent bond. This type of bond forms when electrons are unevenly shared between two atoms. One atom pulls the electrons closer to its nucleus, creating a slight negative charge, while the other atom becomes slightly positive. This uneven distribution of charge creates a polar molecule. The water molecule again serves as a great example of a polar covalent bond. Lastly, we have the hydrogen bond. This bond is a special type of dipole-dipole attraction that occurs between a hydrogen atom in a polar molecule and an electronegative atom. It's a relatively weak bond but crucial in maintaining the structure of substances like DNA and proteins. In summary, chemical bonding is a fundamental process that holds atoms together, forming molecules and compounds. It occurs in four main types: ionic, covalent, polar covalent, and hydrogen bonds. Each type of bond involves either the transfer or sharing of electrons between atoms, leading to attractions that keep the atoms together. By understanding these bonds, we gain insight into the structure and properties of the world around us. So the next time you look at a glass of water or a salt shaker, remember the intricate dance of atoms and electrons that make up these everyday substances. It's a beautiful reminder of the complexity and order that underlies our universe.